Hello everyone. Today I am going to demonstrate waveform generation using a digital to analog converter interfaced with an 8085 microprocessor kit. A digital to analog converter or DAC converts a digital binary value into a proportional analog voltage. The module used here is based on the DAC 0800 chip, which is an 8-bit high-speed converter. It produces an analog output proportional to the digital data applied at its input line. Now coming to the hardware setup, the DAC module is connected to the 8085 kit through a 26-pin ribbon cable. Ensuring pin 1 alignment on both connectors, the module is powered using plus 5 volt, plus 12 volt and minus 12 volt supplies. Port A of the 8255 interface is connected to the DAC input lines and the analog output is observed at the X out terminal using a digital oscilloscope. Now let us understand the program operation. First, the 8255 ports are initialized as output ports so that the microprocessor can send digital data to the DAC. Then the program continuously outputs digital values in different patterns depending on the waveform we want. For sawtooth waveform generation, the program outputs a sequence of weighted digital values stored in memory. Each value increases the voltage in steps, and when the highest value is reached, it suddenly drops back to 0. This produces the sawtooth pattern visible on the CRO display. For ramp waveform generation, the program outputs values starting from 00 and keeps incrementing them step by step until FF. Because each digital value corresponds to a slightly higher voltage, the output voltage increases gradually, forming a rising ramp. After reaching the maximum value, it resets to 00 and repeats, producing a continuous ramp waveform on the oscilloscope. For square wave generation, the program alternately outputs 00 and FF with a delay between them. When 00 is output, the voltage is low. When FF is output, the voltage becomes high. Because the program keeps switching between these two values, a square wave is generated. On the oscilloscope screen, we can clearly observe the generated waveform. When the program increments data continuously, we see a ramp. When stored weights are used, we observed a stepped sawtooth pattern, and when the program alternates between 00 and FF, we see a rectangular or square waveform. This experiment proves that by simply changing the digital data pattern sent from the microprocessor, we can generate different analog waveforms using a DAC. Thank you.